Increased demand for food to sustain the ever increasing population has led to massive increase in both agricultural and industrial activities throughout the world. Such activities have resulted in extensive degradation of air, soil, water environments. Soil degradation causes decline in soil productivity through adverse change in nutrient status, organic matter, structural stability, concentration of solutes and agrochemicals. Soil is the recipient of enormous quantities of man-made waste product. Soil pollution is usually a consequence of insanitary habitats, improper agricultural practices, incorrect methods of disposal of solid and liquid wastes and fallout of atmospheric pollution. Soil plays a fundamental role in the regulation of pollutants in ecosystem. Soil is the interface for most human activity and is greatly impacted by humans. Soil is an important source of pollution in and of itself and as a carrier of pollutants. Water runoff and erosion transfer pollutants from terrestrial to freshwater and marine aquatic ecosystems, and particulate aerosols are important short and long range carriers of pollutants. Soil is an important sink for pollutants through precipitation, absorption and immobilization reactions. In industrial countries, soil pollution is mainly associated with the use of chemicals such as fertilizers and growth regulating agents in agriculture, the dumping of large masses of waste materials on land from the mining of coal and minerals and the smelting of minerals. Toxic or harmful substances can be leached out of such materials and enter the soil. The dumping of domestic refuse and solids on land resulting from the treatment of sewage and industrial wastes. For better understanding of the topic on soil pollution, it has been subdivided into different headings, namely sources of soil pollution and pollutants or contaminants and management of soil pollution. Sources of soil pollution can be divided basically into two groups, natural and cultural. The sources of soil pollution can be further classified as point and non-point sources, agricultural and non-point agricultural sources. Let us study one by one in detail. Point sources. Major point sources include effluent from industrial and sewage plants and effluent from farm buildings or solid waste disposal sites. Non-point sources, pollution from diffuse sources can be related to weathering of minerals, erosion of virgin lands and forests including residues of natural vegetation or artificial or semi-artificial sources. The loss can be related directly to human activities such as application of fertilizer or use of agricultural chemicals, controlling weeds or insects, erosion of soil materials from agricultural farming areas and animal feedlots, construction sites, transportation, accumulation of dust and litter on impervious urban surfaces, stripe mining and others. As pollution has been defined as the addition of substances to water above their natural quality, pollution from non-point sources is caused mostly by man and his activities and should be distinguished from water quality contributions, sometimes called background pollution, caused by the contact of water with rocks, undisturbed soils and geological formations, components from forest litter, migration of salt water into estuaries or other natural sources. Besides the sewage and industrial waste water discharges and erosion from agricultural lands or urban areas, many other activities can cause soil pollution. The cutting down of a forest results in a loss of protective cover and exposes soils, thus causing increased surface runoff and erosion. Stream channelization and removal of the trees and protective grass banks may have significant ecological effects. Sometimes complete destruction of the original biological life in the stream. There are several general characteristics that describe non-point sources of soil pollution are following. Non-point sources discharges enter surface water in diffuse manner and at intermittent intervals that are related mostly to the occurrence of meteorological event. Pollution arises over an extensive area of land and is transit overland before it reaches surface water. Non-point sources generally cannot be monitored at their point of origin and their exact source is difficult or impossible to trace. Elimination or control of pollutants must be directed at specific sites. In general, the most effective and economical way of control are land management techniques and conservation practices in rural zones and architectural control in urban zones. Compliance monitoring for non-point sources is carried out on land rather than water. Non-point source pollutants cannot be measured in terms of effluent limitations. The extent of non-point pollution is related at least in part to certain uncontrollable climate events as well as geographic and geologic conditions and may differ greatly from place to place and year to year. Non-point sources are divided from consecutive operations on extensive units of land as opposed to industrial activities that typically use repetitive operations on intensive units of land. These sources are mostly related to agricultural activities. Agricultural pollutants have their origin in fertilizers. Several other factors also affect pollution loading: soil type, climate, management practices and topography. Land use that produce the most pollution per unit area are animal feedlot operations and farming on steep slopes, forested land and pastures. On the other hand, produce the least amount of pollution, that is approaching background levels. The impact of pollution on receiving water depends on the distance of the source from the nearest concentrated flow stream and on the processes taking place during the overland flow phase of the pollutants transport. Urban non-point sources: the urbanization and related hydrologic modification may cause increased pollution loading that are significantly above the pollution original or background levels. The source of urban non-point pollutants varies considerably, ranging from urban bird and pet populations, street litter accumulation, tire wear of vehicles, abrasion of road surfaces by traffic, street salting practices and construction activities. Urban non-point pollution may contain many dangerous contaminants such as lead, zinc, asbestos, polychlorinated biphenyls, oils and grease. Three basic urban land uses exist: residential, commercial and industrial. Such categorization, however, is vague and can hardly be correlated with pollution generation. For example, residential areas can range from low density, relatively clean, residential suburban zones with 1 or 2 houses per hectare to a large number of people residing on an area of 1 hectare. Similarly, industrial zones can include clean light manufacturing as dirty heavy industries such as foundries, smelting operations, steel mills and mining. An increasing feature of non-point pollution is that with few exceptions, the bulk of pollution is carried by surface hydrologically active areas also are sources of non-point pollution and should be subjected to control and management. Hydrologically active areas include impervious urban and roadway surface, areas with high groundwater table or light soils and frozen soils during spring rains. So, it has been found that even during large storms only, a small part of watershed contributes surface runoff and can be counted as a source of non-point pollution. Agricultural sources. Soil pollution comes from different sources including agriculture. Although agriculture is not considered as a major soil polluter, but some of the practices are now being blamed as sources of pollution following: manures and other wastes from farms and other operations of feedlots or poultry houses. Use of long-lived pesticides, herbicides, fungicides, nematodes, etc. Slaughterhouse wastes, fertilizer runoff from cropland, harvest waste, salt and silt drained from irrigated land or eroded land. Non-agricultural sources. Soil pollution by non-agricultural sources is usually the direct result of urban sprawl caused by rapidly increasing population and a rapidly per capita output. Pollutants come from just about everything that humans do. Agricultural, industrial, commercial and residential activities all produce residues and waste products that pollute air, water, soil. Wrappings, containers, leftover materials, items that have outlived their usefulness and various remnants and products of decomposition can be polluted. These pollutants may become a problem because of high concentrations in particular areas or because of high potency even in low concentration. Materials that find their entry into the soil system have long persistence and accumulate in toxic concentrations, become source of pollution. There are 4 possible sources of soil pollution: inorganic toxic compounds, organic wastes, organic pesticides, radionucleotides. The soil is thus becoming increasingly polluted with chemicals including heavy metals and products of the petroleum industry which can reach the food chain, surface water, groundwater and ultimately be ingested by man. Inorganic toxic compounds, inorganic residues is industrial wastes pose serious problems of disposal. They contain heavy metals which have potentially toxicity. Chromium is low, nickel is high, zinc moderate, cadmium is moderate to high, mercury is low to high, lead is high potential. Industrial activity also emits large amounts of arsenic, fluorides and sulfur dioxide. Sulfur dioxide emits by the factories and thermal plants may make soil very acidic. Fluorides are found in the atmosphere from superphosphate, phosphoric acid, aluminum, steel and ceramic industries. Fluoride and sulfur dioxide cause leaf injury and destroy vegetation. Copper, mercury, cadmium, lead, nickel and arsenic are the elements which accumulate in the soil. They get entry through sewage, industrial waste or mine washings. Some of the fungicides containing copper, mercury also added soil pollution. Smoke from automobiles contains lead which gets absorbed by soil particles and is toxic to plants. The toxicity can be minimized by building up of soil organic matter, adding lime to soils and keeping the soil alkaline. Organic wastes of various types cause pollution, hazards, domestic garbage, municipal sewage and industrial wastes when left in heaps or improperly disposed seriously affect health of human beings, plants and animals. Sewage contains detergents, water softener, borates, phosphates and other salts in large amounts. Untreated sewage, if spread on agricultural fields, will affect the vegetation growth of plants. Dilution of sewage to 1:1000 levels will make it safe and suitable for growing vegetables and crops. Organic waste can be used beneficially or disposed by incineration, composting, recycling, reuse of animal feeds. So, organic contaminants, the main organic contaminants are phenols and coal tars. Phenols, monohydric and polyhydric phenols are byproducts of the coal carbonization industry and are also used extensively as feedstock in the petroleum based chemical industries. Industrial pollution of coal gas and the disposal of mixed industrial waste can cause higher levels of phenol to be present in soils. Coal tars. These are the main organic pollutants associated with coal carbonization. The chemical composition of coal tar is complex, consisting of saturated and unsaturated aliphatic and alicyclic hydrocarbons, aromatic hydrocarbons, phenol, cresols, xylenes and related compounds, and pyridine and other basic compounds, thiophane and related compounds. So, coal tar contamination of gas works sites can be extensively variable, with residual materials being present in some cases in underground pipes and tanks, and extremely persistent deposits. The principal hazards associated with the contamination of sites with coal tars may therefore be direct skin contact with contaminated materials, inhalation of contaminated dusts, contamination of drinking water, phytotoxicity, odor and soil discoloration problems. Other contaminants: asbestos, combustible materials, gases like methane, carbon dioxide, hydrogen sulfide, carbon monoxide, sulfur dioxide. Organic pesticides. Pesticides are quite frequently used to control several types of pests. Nowadays, pesticides may exert harmful effects to microorganisms, as a result of which plant growth may be affected. Pesticides which are not rapidly decomposed may create such problems. Accumulation of residues of pesticides in higher concentration is toxic. Persistence time for some selected pesticides is indicated below. Pesticides like BHC, persistence time is 11 years, DDT 10 years, 2,4-D 2 to 4 weeks, Aldrin 9 years, Diurin 16 months, Atrazine 18 months, Cymazine 17 months, Chloridane 12 years, 2,3,6-dichlorobenzene 2 to 5 years. Mercury, cadmium, arsenic are common constituents of pesticides, and all these heavy metals are toxic. At present, DDT and a number of organochloride compounds used as pesticides have been declared harmful and banned. So, it is due to the persistence of the residues in soil for considerable period without losing their toxicity. This has led to higher concentration of these pesticides in vegetation, animal flesh and milk. Eventually, man has been affected. In view of their demerits, organochlorines have been replaced by organophosphate pesticides, which are more toxic, but do not leave any residue and they do not pollute the soil. Radionucleotides. The radioactive materials or contaminants arise from waste due to mining, uranium and thorium plants, and waste from hospitals, medical and other research laboratories. Radioactivity particles can be deposited on earth surface. Pollution control measures, as diversified as the source of pollution themselves, and no uniform technology can be proposed to control diffuse sources. The traditional means of control is collection and treatment, which works well for most point sources, would be prohibitively expensive for non-point pollution control and could be used only in rare cases when all other controls at the source fail. The best management practices represent a practice or combination of practices determined by a state to be the most effective. So, it is a practicable means of preventing or reducing the amount of pollution generated by non-point source to level compatible with water quality goals. The best management practices should manage pollution generated by non-point sources, achieve water quality compatible with water quality goals, be most effective in preventing or reducing the amount of pollution generated, be practicable. The application of and selection of the best management practices should be based on the type of land use activity, physical condition in the watershed, pollutants to be controlled, site specific conditions. Best management practices for some land use may be similar. For example, stripe mining, construction sites and land under development are characterized by the same disturbing activity and require similar control techniques. Also, park and recreation zones, pastures, idle lands and even some low density residential areas could be considered under one category in terms of or types of control measures that could be applied. Furthermore, the pollutants to be removed or controlled should be those that are greatest concern in improving the quality of surface water and the violate water quality standards. There is a known rule that applies to point and non-point sources of pollution, stating that difficulty and cost of pollutant control is inversely related to the extent of pollutant dilution by runoff. Highly concentrated polluted loads require less expenditure per unit of pollutant removed than pollutants occurring in low concentration. Thus, control costs increase with the distance of runoff travels from source of the point of treatment. So, this introduces the basic philosophy behind the selection of best management practices. A host of alternative strategies exist to restrict soil and pollutant input from non-point sources. The principal strategies include application of emission standards resulting soil and pollutant loss, taxes on soil and pollutant loss, subsidies for reduced soil and pollutant loss, regulation of production process and inputs to allow only those that reduce the soil and pollutant loss from hazardous lands, subsidies for inputs that reduce soil and pollutant loss, taxes on inputs that encourage soil loss and produce pollution. Based on the information furnished on the topic soil pollution, it can be inferred that soil pollution is widespread and comes in many forms and the solution are seldom simple.